Welcome back. In this tutorial, we are going to look at Leetcode's question number 155, that is min stack. So how does the question go by? It's an easy question. Let's look at it. Design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Implement the min stack class. There should be min stack. This initializes a stack object. There should be a method called push. There should be a method called pop. Push basically takes in an integer value and adds it into your stack. There should be a pop that removes the element on top of the stack. There should be popped and then top. Top should just show what is the top element on the stack. And then there is get min, which gives you back what is the minimum element in this stack. And let's see, there's a little constraint here, right? So what they're saying is uh, the minimum element should be retrieved in constant time, right? Minimum element should be retrieved in constant time. The value that they'll be providing to push into the stack will be in this range, minus 2 raised to 31 to 2 raised to 31 minus 1, right? So that is the max integer and the min integer in generally all programming languages. Methods pop, top, and get min operations will always be called on non-empty stack. So they are giving us an assurance that these methods will not be called on an empty stack. So we need not put a lot of checks if it is empty or not. At most 3 raised to 10 raised to 4 calls will be made to this is the maximum number of calls that will be made, right? So irrespective of that, let's try to build it. So what we're saying is stack, right? We're dealing with stack. Array is also a stack. So how are we going to initialize? Min stack. Okay, this is how, if it was any other programming language which was OOP oriented, object oriented, we would have had a class, but since I'm using JavaScript here, we can use min stack as a function, and this will create an object for us. So this dot element is equal to an array. Array is a stack, right? Array behaves like a stack, so we are going to simply use array. This dot elements is what we are setting as array. So now when we type min stack dot prototype dot push, this function is is available to this object here on, right? So push, for push, what we'll do is simple, there's an internal function for array to push items into an array. We'll be simply using that, right? The other thing that we have to do is, look, you can see this dot elements, which is the array dot push. The other thing that we are going to, we are not going to just add the value, we're going to add an object which will have two values, two key values. One will be value, where we'll be passing in, setting in the value that we are getting from the user. The second will be minimum up to that element. So minimum up to that element is being set as, so this dot elements dot length अगर 0 है, if this dot elements dot length is 0, then the minimum will be set to 0, to the value that is being provided, which means that if there is the stack is empty, then the current element is the minimum one. Else it will calculate the previous min for the previous element. Say the stack has got 4 elements, so it will check the minimum at the third element and compare it to the current value, and whatever is the minimum, it will set that for that particular input, right? So every element in this array, every element in the stack will have a minimum value which will tell till that point what is the minimum. So this will be very useful when we use pop, right? Let's do that. So when we do pop, right, we just need to remove the top element from the array, and that is why use top internal function pop for an array, right? And when we take the top, right, we simply take the length of the stack and deduct 1 from that, because indexes indexes start from 0. So the last index would be length minus 1, and we take the value and return that, right? So that's how we get the value for the top element. Okay, now get min. This is where this entire logic will be useful, that for get min. So now we just need to take the last element, the top element in the array, in the stack, and return the min value at that point. So anytime I keep on popping out elements, uh, I'll get the minimum until that point, right? So if there are 5 elements and I have popped out one, right? So until the fourth element, it will have the minimum value. Every element will have the minimum value up to from 0 to that point. So that is why we have implemented, we are storing min value for every element when we push into it. So this is one way of doing it. The other way of doing it is that instead of this, I can simply add this, okay, and I set this dot min is equal to -1, that is the index, minimum index. So far it's -1, and I keep updating this every time I pop or every time I push. But that would be, performance wise it would be poor. I mean, time performance wise it would be poor, because every time I pop, I'll have to find out which is the minimum value in the entire stack and set it to the minimum. But space wise it will be very performant. It would not take any extra space. But in this solution that we have already implemented, we are using a little more space, right? Than space wise, this is not the best solution, but time wise, this is a great solution, because we need not do for pop or for any of the all the functions, all the methods on this class is being run in order of 1, which is order of constant, right? So that's how we solve the min stack problem. See you then in the next video.